So, writing pseudocode. As I mentioned last time, pseudocode is not a programming language. It doesn't have to be exact. And there are some differences between it and Python. Well, there's a great many differences. And I almost don't like teaching pseudocode because then people start trying to put pseudocode into their Python programs. But no, that's like inserting Russian into your English paper. They are completely different things. You can write a paper in Russian, you can write a paper in English, but your English comp class is only going to like it if it's in English. So, one of the key differences is that our programs do not begin with start and stop. The pseudocode does. So, almost tempted to stop having people put that start and stop, but you do it in the flowchart. And then we saw that there's an input statement, there's a set statement, and there's an output statement. If you use the word print rather than output, I'm not going to count you wrong. So programs begin with the word start, they end with the word stop. The words are always aligned. Whenever a module name is used, it's followed by a set of parentheses. Yeah, have we used modules yet? Not much. Very little. Modules begin with okay, I don't care about modules. Each program statement performs one action. For example, input, processing, or output. So program statements are indented a few spaces more than the word start, like just a tab key. Each program statement appears on a single line when possible. Or if the statement line is so long, then you just indent the line underneath it. Program statements begin with lowercase letters. No punctuation is used to end statements. All right, so if we go back and look at this, right, this is pretty much like what we were looking at on Wednesday. You can use capital letters, but typically only in the variable names, like that. You can have multiple levels of indentation. If you have an if statement, it'll look something like that. Pretend that PowerPoint did not capitalize that. And then the code underneath that, or the logic underneath that, is going to be indented further, right? Like that. Just like we actually do in Python, except in Python we put a colon there after the end of the if. And again, if your pseudocode starts looking like Python and you put colons at the end of your if statements, I'm not going to count you wrong, even though it says no punctuation. So, drawing flowcharts. There's several different symbols. There's the input, output symbol, which is a tilted rectangle. We got to give it a fancier name, a parallelogram. Yeah, but honestly, the diamond and the squares are parallelograms too, so that doesn't really distinguish it. I'm just going to use the childish term tilted rectangle. The processing symbol is like math statements and function calls. And it's just a regular rectangle. And then the output's in the same shape as the input. Some textbooks show a different shape for output. They show like a terminal, a video screen kind of shape, but we're just going to use the same one. We're going to follow the book lead. Flow lines are the arrows, and then there's these things called terminal symbols. The terminal symbols are the pill shapes, the ovals, also called lozenges. Sounds like a cough medicine. I'm probably just going to call them ovals. Like this. Start. Input my number. My answer equals my number times 2. Notice that the pseudocode has suddenly lost that set in front of it that they were using earlier. So I don't mind if we lose the word set either. We discuss. And then output. So repeating an instruction. This program only works for one number. If you wanted it to double 10,000 numbers in a row, what would you do? You'd run it 10,000 times in a row? Or you'd copy and paste that code 10,000 times? No, you would create a loop. A loop is something that just repeats it over and over and over. It's an efficient way of programming. So here they have an example of they just copied and pasted those statements that got input multiplied by 2 and output it over and over and over. Somebody copied and pasted it over and over and over. You wouldn't do that. anytime you wind up like having more than 2 copies of a chunk of code in your program, you need to think, did I need to put that into a function, or did I need to put that into a loop? And I will use the term function. The book calls them modules. Almost every program language calls them either a function or a method. I may slip up and call it a function when I mean module. I'll try to stick to the word module, just realize that they mean the same thing. And so let's give an example of a function. I'm going to pop open idle. I'm going to create a new file. File, new file. As always, I'm going to put some information up at the top about what we're doing. We're on lecture D, it looks like. All right. So they have some code that's asking for some input and doubling it. But I feel like putting that into a function. I feel like putting it into a module. So I'm going to put DEF double, because it doubles the number. Parentheses, in parentheses, colon. Now I'm going to get the input and I'm going to convert it to a float all in one line. Nah, I'm not going to do that. I'm going to keep separating them for now. Matter of fact, I'm going to break into 3 statements. This is the long way of doing it, but we'll start shortening it dramatically. Print, in parentheses, quote, enter a number, end quote, in parentheses. Then I need some input and I need to store it in a variable name. They had some fancy number, variable name, I'm just going to call it n. N equals input, parentheses, in parentheses. But I like to put something between the parentheses telling them where to type at the very least. So inside the pair of parentheses, I'm going to put a quote greater than end quote sign, just so that they have like a cursor on the screen pointing to where they need to type. Now let's double it. N equals n times 2. N equals n times 2. And do you need to put all sorts of spaces like I put in? No. I do that just to make it easy to read. And now I'm going to print the result. Print parentheses quote doubled space is end quote comma n in parentheses. All right, if I wanted to run that chunk of code, if I wanted to double 5 numbers in a row, sure, I'd put it in a loop for reals. But for now, I'm just going to show you. Double, parentheses, in parentheses, and hit enter. And then I'm going to type that in like 4 more times. I could use copy and paste or whatever. This is unindented. It's not part of the module. So I backspaced it so that it was against the margin. Double parentheses, in parentheses, double parentheses, in parentheses. I think 3 times enough. So I'm going to stop there. So when I run it, it's going to repeat that double module 3 times in a row. Save as, call it lecture D with no spaces, put it in a good directory, not in that Python 32 directory, whatever it was. Lecture D. Now I'm going to run it. You can always run things really fast by clicking F5, but on some keyboards it's not convenient to click F5 because you have to hold down some option key to get that to work. Anyways, enter a number, 10. Oh, look at that. I was an idiot. 10 doubled is 1010. Well, I guess so, huh? 555. Doubled is 5555. Okay. What's happening here is I got input as a string. I forgot to convert it to a number to do math. So I need to insert a line into my module up here. Before we multiply it by 2, after the input statement, there needs to be 1 more line of code. n equals float, and we've seen this, float parentheses n. Can't believe I forgot that. Pretty soon, I'll probably get to the point where I make my input statements look like this. I'm just going to type it in as a comment. You don't have to type it in. Fine if you want it. Float, parentheses, input, parentheses, quote, enter a number, space, angle, end quote, in parentheses, right? That replaces all three of these lines with one line of code. It's a little bit more complex looking, but at least it's one line of code. And I wouldn't have forgotten to do that step, right? I wouldn't have forgotten to do the float before the math. So now when I run it, hopefully it'll behave correctly. 10 doubled is 20. All right. 555 doubled is that. How about 0? 0 doubled is 0. Looks good. Do you have to use modules in your code yet? Certainly not. If you've taken another programming course and you're familiar with the idea of writing functions and stuff like that, and you want to start organizing your code like that this early in the game, that's totally fine. All right, so this is an example of a module, and the reason I'm introducing it so early is that there's like 4 things you need to know how to do. And as soon as you know how to do those 4 things, you are already a programmer. But if you understand the idea of loops, and you understand the idea of writing functions or modules, and you understand the idea of writing decision statements, and I said 4 things, and I'm only coming up with 3. By the time you understand those 3 concepts, you're already thinking like a programmer. And so the idea of a module, I did start the recorder, did I not? Yep. Is that it's a chunk of code with a name, and so you can execute that module as many times as you want and anywhere in your code. And I didn't have to copy and paste that code 3 times in order to get it to repeat 3 times. I just had to call that name 3 times. And I could even save this file somewhere and I could import it. And so I don't even have to write this code again. And I don't have to paste it into my program again in order to be able to use it in another program. So yeah, we're getting way ahead of ourselves here. I think this is a great book, but the chapter 1 organization is pretty weird. So using a sentinel value to end a program. What's a sentinel value? A sentinel value is like if you say enter a test score or -1 to quit. That -1 is an invalid piece of data that you use specifically to end it. Or like if it's reading in data from the end of from a file, once it hits the end of the file, it might hit an invalid value called end of file. And so that looks something like this. No, it doesn't. We're going to write it up ourselves. Let's go in and write a different module. We're going to call it triple. DEF triple, parentheses and parentheses. And you see the syntax here? I'm going to use that one to condense it down to one line. N equals float parentheses, input parentheses, double quote, enter a number, greater than, end quote, parentheses, parentheses. And we're going to write a loop so that it asks us for these numbers over and over, but if we ever type in a 0, we quit. So we need to let them know that. So before that greater than, I'm going to add a little comment here inside. I could put it inside parentheses. How about just skipping that, because that'd be entirely too many parentheses in a single line. So before that greater than, enter a number or 0 to stop. Space. Like that. We're telling them what they need to do to stop. I'm going to add a comment here just to tie it back into our lecture. 0 is our sentinel value. Because there's more than one way to stop a loop, right? We could just say, you know, do you want to play again, right? We could ask them, and then they type in Y and N, and that's separate from, you know, do you wish to triple another number? So that's called user query. It's a separate way, but it requires 2 steps, right? They triple a number, then they have to answer a question as to whether they want to continue or not. And then they triple another number, and they answer the question again. This lets them do it in 1 step. But we're kind of dependent upon the fact that we need a special value to let us quit. And I just chose 0 arbitrarily, right? Maybe we really did want to triple 0, right? And so maybe that was a bad sentinel value. Okay, so while, next line, in, and I'm going to say not equal, but the way you type in not equals with the exclamation mark. Exclamation mark equal 0, colon. And I'm going to add a comma in here and say don't do n greater than less than 0, because that may have been how you wrote it in math classes, right? If n was not equal to 0, you might have used greater than, less than. You'll never see that. So kind of dump that out of your mind until you get back into another math class that requires it. Okay, so this line's going to be indented under the while statement. Let's triple the result. N equals n times 3. Let's print the result. We're still indented. Print, parentheses, quote, tripled is, end quote, comma, n, in parentheses. And now we need to ask them for that number again. And honestly, I don't feel like typing in that entire float input statement, so I'm just going to copy it and paste it right here, but make sure it's indented with that print statement. So I'm going to copy that entire line. Normally I would hit Control C and Control V for paste, but I'm doing it visual, make it easier to follow. And now we're done. I'm just going to add a comment that says end while. And since it's just a comment, it's going to be with a hash in front of it. And that's it. That's all I need, except I actually need to call it. So down here where we were calling our double code, I'm going to put a call to triple. Just one though, because it can repeat as many times as we need. So completely unindented, back against the margin, put a call to triple. And as a matter of fact, let's comment out those calls to double. I don't want to enter any numbers for doubling anymore. Don't want to do that. I could even delete them, but I'm just going to leave them there. So if I have not made any syntax errors, you should run. Enter a number or 0 to stop. 6. 6 tripled is 18. 20. 20 tripled is 60. Negative 999. Okay, it seems to be working. So if I enter 0, it did stop. Maybe it would have been nice to print a message telling why we stopped, like saying, okay, done, or something like that. So maybe after end while, I'm going to put a print that says, okay, done, or print, parentheses, quote, okay, comma, done, tripling. Is that a word? Yeah, if doubling's a word, tripling's got to be a word. All right, end quote in parentheses. Now, is this looking more complicated than you wanted on day 3 of programming or whatever? Maybe, but it's because their chapter 1 talks about modules, and it talks about loops, and talks about sentinel values, which is stuff that ought to be in later chapters. So I'm sure they're going to get back to it again. I mean, I know that for a fact. I've taught from this book. But we're going to have seen it one time. Doesn't mean that I'm going to ask you to write a program that has a loop and has a sentinel value and has, you know, functions. I'm not going to ask you for homework like that yet. But I always like for you to see something at least one time before we see it again, so it burns into the brain. All right, I'm going to run it again, and I'll check with y'all, see how y'all are doing. So 99, great, that's tripled. 88, that's great. I'm going to hit 0, and it says, OK, done tripling. And if that was the end of the program, I might just make it say, OK, goodbye, or whatever. That way they know the program's done. Now, one thing that people wish they could do is after you run the program, you know, they type in something, they get it to quit. They wish that they could start typing it again, right? Well, no, I want to run it again. 100, I wanted to triple that. No, you always have to go back to your original code and run it again. You can't run it again from the shell. That's not strictly true, but I'm not going to show you the exception. I'll mention it. Once you've defined a function and run it once, you can call it from within the shell. Maybe I'll show you. How's it going? You got rid of text going?
Yeah.
No problem.
It might be in a weird folder.
What line number is it confirming? Okay, put your cursor over here, and this one's up and down until one line comes over. Okay, line 19. Can't multiply sequence non-end when in. Oh, you see that? Delete all that and just make it n equals n times 3. Because that's actually the print statement here. Okay, so what we're going to do is, yeah, make that say 3 there. And then on the next line, make it say just print out of that.
I don't know.
I think we'll be good to go. Oh, I'm going to let's run it and see. All right.
Actually, I was having the same problem too. Okay, so 924.
Oh,
Yeah.
just 2 in the word print. It's always easier for somebody else to print to proofread. So you're just going to have to go to line 24 or 19 or whatever it is. We have 2 in a row. Yep. Okay. Anybody else? Uh-huh.
So if you want to have a question, there is one of the significance of the button last line at the bottom. So I moved it, and that's just
Right, it goes into an infinite loop. I'm going to go up there and explain it to everybody, okay? So, this code looks like it's got some redundancy in it. Because you copied and you pasted a line, right? And it didn't I already say by the time you're copying and pasting, it's kind of lame? It is, but the reason we copied and pasted it is because without it, it never asks for a new number, right? So if I deleted it or I commented out this second line right here where we did float input again, when I run it, you get only one shot at entering a number. And while that's cool, it's not what we want. So if you're inside a loop, this is a test expression here. If the value that is being tested never changes, the loop never exits, and so that's an infinite loop. Could we have written this so that it didn't duplicate this line? Yeah, but it would have required an if statement in there instead. And so I personally don't like repeating that line, and later on I'm going to show you most likely how I would have written it, and it would have needed that if statement. But I'm going to leave it alone. Does that make sense? Yeah, okay. So, that 0 is arbitrary. I could have made it type in -999 to quit, right? Not gonna, because then I'd have to change it in 3 places in my code. I'd have to change it there, I'd have to change it there, I'd better change this comment, and then I'd have to change it there, right? So, you can pick anything as a sentinel value. It should be something that's not actually valid data. Like if you're making something that adds up test scores, hopefully your professor is not so much a jerk that they would give you a -1 as your test score, right? Even better is if they allow you to type in a Q. And we could have done that if we really wanted to, right? Enter a number or Q to quit. Oops, get rid of that. So that signal value, if you're reading from a file, can be the so-called end-of-file marker. And this is showing logic for it. But it's showing don't do it, and I don't want to show you bad logic, so I'm just going to skip that page. Okay, so, all right, now we're back to Chapter 1 stuff. The text editor. The text editor is used to create simple text files. And you don't have to use Python and idle to do it. You could even use Notepad to create a text file, and then you could run it from the command prompt. And I'm going to go into PyCharm and see if I can get it running quickly enough. Those of y'all using your own laptops aren't going to be able to do this, but if you're using a school computer, you might try this. It's a different editor and it's more functional. Maybe I'm going to recommend that we switch over to it, but you wouldn't have to because we have idle. So I started to type in PyCharm down here, and I'm going to run it. It takes longer to load than idle. A lot longer. Come on. Of course, these school computers are not exactly gaming machines. Yeah, I confirm that I've read I'm sure that I have all 5,000 lines of code. All right. I mean, like to use iTunes or Google Music or whatever, and you have to supposedly read 70 pages of legal documents. So you're going to do that. Okay, so it's just sitting there waiting for PyCharm to load. This is probably one of the reasons why I start veering away from it. It comes up to this screen. Create new project. In PyCharm, you organize your code into projects, and you can put multiple PY files into a single project, which is pretty cool. So not only would you come in and say new file, but you have to do new project first. What kind of? I just want pure Python. And then click create. And if you don't do this right, or if you don't, if I skip a step and you don't skip it and whatever, right? Shows tips on startup, sure, why not? Creating virtual environment, okay, sounds great. Running the install, oh boy, you got a lot to do. Joni, does it ever stop doing all this?
Yes, eventually.
Hopefully this is a one-time thing. Alrighty. Close that. Alright, now I've got a project folder here called Untitled. And I'm going to put a new Python file in this project folder. So I'm clicking on Untitled, and I'm going to right-click on it. Nope, it's not responding to right-clicks. It did on Joni's. Nope, it finally did. And I'm going to click on New Python File. You see what I did? Once I finally get into the project screen, if you are following along, if you've gotten here, and it's okay if you didn't, New Python File. I need to give it a name. I'm just going to call it sample so that it doesn't look like lecture D and you're not implying that you actually have to turn this in as well. And then it comes in a Python editor. This is crazy, man. All right, and then we could type in some kind of command like print, parentheses, quote, hello, end quote, in parentheses. What if I type in something wrong? Print with 2 T's. Is it going to underline it and tell me that I got it wrong? It'd be really neat if it did. I'm not seeing that it did, so I'm going to run it and see. Yep, see, it underlined it. That's pretty cool. It caught the error even before I ran it. That can make this a heck of a lot easier to edit our code, right? Because some of the errors I corrected when I was wandering around, you just doubled up an in on a print statement, easy to do, hard to proofread your own code. It's kind of nice to have an editor that proofreads your own code. So tell you what, when we come back in Wednesday, why don't we play with PyCharm? Those of y'all who use your own laptops, why don't you go ahead and install PyCharm, right? And if you don't want it, that's fine. You can keep using idle, because obviously I could have just written this in idle, right? But if it's a more sophisticated editor and it makes us more productive, that'd be pretty cool. All right, enough of that. And then when you were ready to upload your code, you just have to find out where it's stored sample.py. If you click File Path, no, Show in Explorer. If you click Show in Explorer, you can get a hint as to where it saved that sample.py file so you could upload it. Looks like it's in my user directory inside something called Project, Python Projects Untitled. You could probably save that default, but hopefully it'll be easy to find if you have the ability to right click on it and tell you to show it inside the Mac Finder or in Windows Explorer. Just right click on the file, Show in Explorer. Who actually got that going? I want to get some warm fuzzies. All right, cool. When we do it again on Wednesday, I'll go through more slowly, and everybody is trying to get it to work. All right, so that's the text editor. Meanwhile, an integrated development environment gives you the editor, the compiler, and other programming tools all in one place. And then there are some extremely complicated, extremely powerful ones. They mentioned Microsoft Visual Studio. There are other ones like Eclipse, an open source one, and NetBeans for Java development, although Eclipse can do Java development too. And Microsoft Visual Studio can actually do Python development. So if you're a C programmer, C++ programmer, and you feel like doing Python in the same environment, in the same Microsoft environment, you can. What's the big deal about integrated development environments? If I didn't have them, I would have to edit the file with Notepad, blah, 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 save it, exit Notepad, or open up another command prompt, change its file type, run it. Now I'm ready to try to run it. So I come back in here, I do dir, I see all my py files, and I try to run the py file right from here. So anyways, I'm not going to do that, but I could. You can always create a program just by using a simple text editor. We'd much rather use an IDE, an integrated development environment. So command line. The command line is a location on your computer screen where you can type in text entries. In Windows, it's CMD, and there's other command line prompts as well that you can either install for Windows or come default with it. The Unix command prompt, bash, B-A-S-H, which is also in the default Mac one, is going. I believe it's either installed by default anymore, or you can certainly go and install it, and that way you can enter Unix shipped shell scripts into it. But anyways, so that's a command prompt, as opposed to the graphical user interface, which is, like this, where you get buttons and stuff. We're going to be writing command line programs. By default, or not by default, unless you write a graphical user interface program, when I click run, it runs my program in the shell, so it gives me a command prompt. If I wanted to run that program again, since it's entirely in a function, I could call it again right here from the shell. I could type in python, parentheses in parentheses. I don't know if this will work in PyCharm. I shouldn't have closed it. I should find out. And it'll run it again. No, it won't. Forget it. Why did I do that? What's the name of my module that I created?
Lecture D.
Yeah. The lecture D is the name of the file, and then we had two modules inside it. One of them was triple. Right? And so I'm actually running it straight from the command prompt, which I never do, just to show you that you can. So here's an example of code written in a different programming language. And this is following the C syntax, and the C syntax is shared by C, C++, C#, Java, JavaScript, a whole bunch of languages, and it's where you use these curly braces to mark your code, and rather than a colon on this statement up here. And if you get to use curly braces, then the indentions aren't all that important. If you mess up the indentions, it doesn't care. It's nice to have them there to read, but it doesn't care. Python cares very much because it doesn't use curly braces to open and close your blocks of code. We're going to see a lot of examples of code written in other languages in this textbook, and we're just going to kind of skip past them because they're not Python. Running our program from a command prompt. If I went and found the directory that my Lecture D program was written in, I could run it straight from the command prompt. If I do save as just a spot where it is, okay, it's in desktop CIT1113. I know there's an easier way that you can start a command prompt right inside a directory. I don't know how to do it, so I'm going to launch my command prompt. I'm going to go into desktop, CD desktop, CD means change directory. I'm going to CID into 1113. I'm going to do dir *.py. The asterisk is called a wildcard because it will find every file that ends in .py. In Linux, on your Mac, on a bash script, you type in ls, I believe. Anyways, and there's my Lecture D file, so I'm going to run it by typing in python space python d.py, and it runs my program. Or not, forget it. Did I goof something? Oh, it's called Lecture D. Yeah, you were just telling me that, and I goofed it. Python space Lecture D.py. And it starts running my program. Enter a number 0 to start. Right, now it's tripling all my numbers until I hit 0. So you can run your code from the command prompt. Or you can write a graphical user interface. Here's what our program would look like if we had written it as a graphical user interface. Please enter a number, and I guess they type in that little into that box, and there's no button for them to click, so maybe they just hit the enter key. Honestly, don't think that would work. I mean, we could make it work, but anyways, right, you get a nice little window, and you can move the window around and stuff like that, and that's what users want to see. They don't want to see, black text on a green background, or vice versa, or run it inside of the idle shell. So people have been writing computer programs since the 40s. However, they were very difficult to write. I think I've shown you things like didn't I show you slides like this, pictures like this? Maybe I didn't. Say yes or no. Is this a familiar pic?
Not these particular ones.
All right. Okay. So computers during the 40s. How did you write your programs? You didn't have a keyboard. You didn't have a terminal. Instead, you programmed your programs in by flipping dials, and then you wired the modules together with patch cables, like you're a telephone operator in a Spencer Tracy movie in the 40s. And so that is not easy to do at all. And it's interesting, most of the first programmers were women back in those days, because women weren't really allowed or encouraged to go into engineering fields, but during the war efforts, you needed some extremely bright people in order to do things like programming, and so they would hire, like MIT grad students and professors and stuff like that, to get them into the war effort. And so a lot of the early programming languages were actually written by women. So one in particular was a woman named Grace Hopper, who created the COBOL programming language in the 50s, which is still used today. There's lots of government code and banking code written in COBOL. She was also the person who created made the reference to the first computer bug. That thing ran on vacuum tubes and relays, which are mechanical switches. And a vacuum tube is just a light bulb, right? And if it's off, it indicates that it's a 0. And if it's on or has varying stages of brightness, then it could contain a number. And so if you had a bug stuck in one of the relays, the mechanical relays, wouldn't work, right? And so they tracked down a problem, and she wrote it down, in her notebook and called it the first computer bug. That kind of implies that the term was actually used before then. Maybe Thomas Edison, whatever, called something a bug. That would be the first computer bug. However, we don't want to flip switches. A more recent computer looked like this. And when I say more recent, a home computer that you'd buy in the 70s if you were a hobbyist looked like that. And if you were going to enter programming code in this, again, you would flip all the switches to create some binary letter. And you'd flip another switch, which is like the enter key, and there you've typed in one letter of your program. And you flip more switches. Now, obviously, you didn't get any real good code going like that. But it was a computer. You bought it, you built it, you ran it, you got some blinking lights, and then people invented keyboards and ways to hook it up to your television set, and so you could actually do something a little bit more useful for it. Didn't want to do that. It's much, much, much better. Okay, here, let's go into Hello World in Assembly. If we wanted to write hello world in our language, we would put a single line that said print, parentheses, quote, hello world. This is how you'd write it if you didn't have a computer language nowadays. If you needed to communicate directly with the chip, you'd write this program, you'd save it, you'd run what's known as assembler on it, it would create some machine language, and then when you ran it, it would tell the chip to print hello world on the screen. And so this is an insane amount of work to do in order to just print hello world. You can see that, and this is like what the moon landers, and the space program used in the 60s. And it's amazing that all of that could be made to work. So if you wanted to get this to work, that's for the birds. We would not want to do that. We want to be able to do things like this, write almost in English. I want to print something. I want to get some input. These are called high-level languages. That low-level language, assembly runs very quickly, and there are still a few people who write, code like that. Not very many. It's the creation of high-level programming languages that made computers a lot easier to program. Without them, people wouldn't be doing much with them, right? You'd have people who were highly specialized and who could write those assembly programs, but they wouldn't be all over the place. People wouldn't be writing games and putting them on Steam or, apps to put on their iPhones and stuff like that. So the newer programming language look more like natural languages. They have algebraic expression, x equals y plus 2. So they're easier to use, and you can contain self-contained modules or program segments that can then be linked together in a variety of ways. So the major models or paradigms used by programmers, it's pretty much divided into two. For some reason, they skipped the third. Procedural programming is what we have been doing in here. We've defined a procedure, and it runs from the top of the procedure to the bottom of the procedure. It's called procedural programming. Procedural programming uses like individual pieces of data, and you get user input, and you do something with it, and you output it. If you're going to write something like a graphical user interface, even as easy, as simple as an editor like that, it would not use a procedural concept, and instead uses the idea of object-oriented programming, where an object is something that is some data that has functions attached to it. So like a menu is data. And the menu has 4 things listed in it, and what are the functions that are attached to it? Well, it has to respond to being clicked on, to being dismissed, all of those. So we see little pieces of data occasionally that work like that. I don't know how to give a good example of it yet in here. We will be writing classes to do object-oriented programming by the end of the semester. But it's like I am a person, and if I have a whole bunch of information in me, and I have commands that are attached to me, like eat, right? You tell me to eat, I know how to eat. Sit, you tell me, I know how to do all that, right? Objects are the same way. You have a printer object, and you can tell it to print a document. You can tell it to, stop printing, to clear error message, all of that. So it has all these functions that are attached to it that your program can then call. And we're getting close to the end of the lecture. We're getting close to the end of the PowerPoint. We've got to finish it. So object-oriented program focuses on objects or things, which are groups of data and functions attached to it. And it models kind of the real world much more than procedural programming does, right? Because we think of things in terms of objects, right? I'm an object. My TV is an object. It's got some functions attached to it. I can change the channel on it, right? I can enter a settings mode. I can turn it off. I can switch, the input mode to play with my PlayStation, right? It's got all these functions. That's how we think of things, what we do with things. But to learn programming, we got to focus on that first, because you can be sure that even inside object-oriented programming, there are going to be procedures and functions that are just, start at the top of this module, run some code, get to the bottom, and then return. And so our summary. Hardware and software, we know what those are. They're done to do input, processing, output. If your logic isn't done correctly, it won't work correctly. Right, if we'd ask for a number to triple, but then we divide it by 3, that's the wrong logic. Logical errors are much more difficult to locate than syntax errors. When I was wandering around, it was easy for me to find double ends in your print statements. But if there had been a mistake in the logic, it'd take a lot longer to figure out. You can use flowcharts and pseudocode to plan the logic. You avoid infinite loops by testing for a sentinel value. An infinite loop is just one that runs infinitely, like when I commented that input statement out. And we use a text editor or IDE to enter your program statements. All right. So once you've looked over the PowerPoint yourself, and once you have CEngage going, go into Modules, scroll down to CEngage. Why is that grayed out? Skip the Chapter 1 quiz unless you really want to. I feel like even deleting that link. Click on Unit 1 test. Don't do it now. Don't do it now. You're just going to go into the Unit 1 test when you can, and you're going to answer the questions. And if you don't like your score, do it again until you get 100 on it. That's why I don't put due dates on these things. And without the due dates on them, you have to take responsibility yourself for remembering to go and do them. So, first question. Writing a program is known as coding the program. When you write it, you're coding it. Now, I'm not going to answer all 20 questions. But it told me that it was correct. Good deal. Now, I can't go back and fix my question, but I could take it again. All right. Let's stop for today. We'll save signing homework until we've actually covered more coding in Chapter 2. So let's stop here and make a Dropbox and all that.